Hello everyone, welcome back to MindMatrix YouTube channel. So right now we'll be giving the answers for slot 2 exam GATE CS 2024. Okay, so let's just start that. Okay, before that everyone can just share this session with everyone and we'll be start solving the problems now. Okay, so let's see what do we have now. Okay, what are the different problems we are having. Though at this point of time we haven't got enough of questions, so we have a very limited number of questions, but let's focus on that only and let's start with that. Okay, so I hope you are already aware this is my profile that I'm right now the final semester pursuing student at ISC Bangalore, and I'm Tech AI student, already having 3+ years of experience, and then you can see all that stuff. Okay, and we have these courses over here. If you just have a look at this carefully, we have this placement course as well. That is an additional benefit you get when you enroll with us for any GATE CS, GATE DA, or GATE CS plus DA course. Okay, if I talk further, so we are going to have national scholarship test on 17th of Feb from 9 AM to 12. Don't forget to register for that. Okay, 12 noon basically. So we are going to have this test. Go and register. We have the scholarships available for different students, basically based on the rankings they'll be getting. Apart from that, there is the operating system course, which is available free of cost, a premium quality course this is, okay, which is available on our website. You can definitely go and check out to know what a premium quality content looks like. Okay, the high quality content we are having. So you should definitely check out that so that you can make up your mind whether to go with us or not. And I'm damn sure if you just go and check out that, you'll be happy to come up with us, and we'll be working together to make sure that you are getting a good rank next year. Okay, so now let's just start focusing on the questions we are having. So the first question I'm having is from the calculus. That's basic. Okay, let's just talk about that. So the question is something like this. So it says that fx is equal to fx not equals, but something like this. Okay, something like this is there. Fx plus f of 2 minus x equals 1. This is already given to us, and then what is being asked is what is the integration of f of x dx from 0 to 2. This is we were asked in the question. Okay, so how do we solve this? This is a very simple problem we are having. Okay, how do we solve this? Let's have a look at this. So let's say this is our integration. Okay, let's just start with this. So I know this is going to be equal to 0 to 2. Let me just write what would be my fx. You just use this equation. Your fx is going to be 1 minus f of 2 minus x. I hope you agree with me on this. Okay, so this is going to be very simple, and do tell me in the chat if you're there that how many of you have done this question correctly. So what you'll do, you'll just write it like this: 1 minus f of 2 minus x and dx, something like this. And I hope you know this property. If we have something like this, that okay, pq, okay, let's not make pq, let's make it like 0 to p, and if I have fx dx, then it is also equal to 0 to p only. The range remains same, but you can write f of p minus x dx. So this is the property of our indefinite integral. So I will be using that only. So I hope you know that. So this I have just this has to be bracket over here. So yeah, something like this. So I have just broken it up, and what I'm getting is something like this: f of 2 minus x dx. So I hope you know, as the range is this one and you have something like this, so this is equivalent to saying this thing only. Very simple. So, and what is it going to be? It is going to be x, and the integration for nothing, just 1, is going to be x, and the range from 0 to 2. And what is it going to be? Integration of 0 to 2 fx dx, the same thing. So on the left hand side you have it, on the right hand side you have it. You just make it, just shift it over here. What you'll be getting is something like this: twice 0 to 2 fx dx would be equal to, what is it going to be? You just put 2 and minus 0. What do you get? 2. So this integration would be 1. The answer is going to be finally 1. Very simple. Okay, it's going to be very simple. I hope it's clear. I hope it's clear. Okay, this was a very simple question. Now let's move further. Let's talk about another question what we are having. And before moving further, these are the QR codes you can definitely scan to join our Telegram group where you can discuss the problems with us. Then we have a QR code for our WhatsApp channel as well, and you can scan the QR code for the website and that will land you on our website. Okay, so let's move further. Let's talk about the next question. This was a very simple question, very simple question. It was less of a probability but more of a rather I should say a counting problem. Okay, because the probability concept required was not too much. It was very simple. Let me just tell you that. So it was mentioned that we have 6 unbiased dice available. 6 unbiased dice. Okay, and we are rolling all of them. We are rolling all of them. Okay, all of them. Now what is told to us is that what is the probability that all dice shows up different numbers. All dice shows different number. So it's very simple. What do you think it should be? What do you think? What do you think should be the answer? Okay, different numbers. So it's very simple. If I talk about the sample space, what is it going to be? So you know it is going to be how many possibilities are there? For each of the dice, I have 6 possibilities that any of those 6 number 1, 2, 3, 4, 5, 6 can come. For each of these dice, how many dice we have? 6. So sample space is going to be 6 to the power 6. If I talk about our event, let's say A is the event. So if I just talk about that, what is the size of that? What is the size of that? So I'm talking about different numbers probability. So what are the different ways I can have all these different numbers? So when I'm saying this, what is it? We are having 6 different numbers. What are the ways I can get these 6 numbers? So it's like a simple permutation problem I'm having. Each blank is representing me. Each blank is representing me a place where I'll be getting a number from my dice, and I'm saying all of these number would be different. So if all of these number would be different, I'll be getting number from 1, 2, 3, 6. 1, 2, 3, 4, 5, 6. So what are the possibilities I'm having? 6 factorial are the different ways I can have by arranging all these 6 different numbers. Okay, so what is the event space I'm having? That is going to be 6 factorial. So if I talk about the probability, that is going to be simply like this. Okay, I hope you know these basics. Okay, I'm just writing the size of my event set. Okay, so what is it? 6 factorial for the total possibilities in which I can have different numbers appearing on 6 dices, and in the denominator total possibilities available. So this is going to be my final answer. Very simple. Okay, now we will be having another problem, which is the last problem. I guess I am getting one more problem. Let's see that. Okay, so before moving further, you should definitely check out our courses on our website, which is written over here, www.mindmatrix.net.in. okay, where we have these premium courses, and this placement course is, you know, an additional benefit you get at no additional cost. Okay, apart from that, there are projects also which we will be, you know, providing you. It won't be like, okay, we are just providing you. We'll make you do that. Okay, and you'll be learning through the projects as well, that how does good quality projects are created. And those won't be very simple one. Okay, linear regression based. Those would be some good projects you'll be having. Okay, like recommender system, deep learning based. Okay, computer vision based, natural language processing based. Okay, I hope you are getting that. And definitely check out our NST, which is going to be on 17th Feb. You can just go to our website and register for that. It's free. Okay, the test is going to be 9 AM to 12 noon. And for more details, you can definitely check out the video posted by Anshul sir, okay, on our YouTube channel. And definitely you should be looking for operating system course, which is like the unmatched quality content, premium content at no cost right now, because it is available for free. Okay, on our website. You should definitely check out that to know what exactly a premium course looks like. Okay, so let's come back to the problem solving again. Let me just erase this part. Okay, let me just talk about one more problem over here. So that was a question on chromatic number. So let me just draw this figure first. Initially you will feel like, okay, what exactly is this figure? Okay, and the question is, you need to tell the chromatic number. You need to tell the chromatic number. It is something like this. Okay, the graph was something like this. Oh, sorry, there is this mistake. Let me just correct it. Yes, so it has to be something like this, and then we are having something like this, like this. Okay, what we are having, so like this, we are having like this. Apart from that, we are having it like this, this like this, this like this, and like this. Okay, so this was a complicated graph you can see over here. Okay, A B C D E F G H. Okay, so we have 8 sides or 8 vertices over here. Sorry, not 8 sides, 8 vertices over here. And then you need to tell the chromatic number. Okay, chromatic number has to be told. So how do you do that? If you have just focused upon how I have drawn this, then you had the answer. Okay, if you just focused upon how I have drawn this, then you had the answer for this chromatic number. Okay, if you just look at these, you'll find a number of parallel lines available. You'll find a number of parallel lines. So let me just draw it once again for you. Okay, so first of all, I'll draw this figure of 8 sides, cycle of 8. Let me first of all draw that only. Okay, so we have these A, B, C, D, E, F, G, and H. And then let's start observing, okay, this thing. So let me just mark this up. So this is red, this is red, this is red, and this is red. Okay, let me just mark something differently over here now. This is green, 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 and green. Okay, I guess right now we have 2 chromatic number. Let's keep on adding the sides now. Okay, so we have this, we are adding this, no issue. Adding this, no issue. Adding this, no issue. Adding this, no issue. We are adding these as well, no issue again, no issue again, no issue again, and no issue at last over here as well. So the chromatic number over here is 2 only. I hope it's clear. Okay, so chromatic number for this particular graph is 2 only. I hope it is clear. Okay, so these were the questions I was having, and right now we haven't got some more questions over here. So these were the only questions we have it till this point. So let me just go through these things again. Okay, what exactly we are having and offering, and then Tathagat sir will be joining soon. Okay, Tathagat sir will be joining soon. Let's just wait. So before going, I would like to just tell you that you should definitely check out our courses over here. Okay, these courses, and I have already told you that this complete placement preparation course is available at no additional cost. Okay, that is available as an additional benefits when you are enrolling with any of these other 3 courses, which is GATE CS course, GATE DA course, or GATE CS plus DA course. Okay, and the prices for this, that is already given. If you are thinking that okay, you need a scholarship, so we are going to have a national scholarship test as well, which is going to be on 17th of Feb from 9 AM to 12 noon. Apart from that, you should definitely check out the video made by Anshul sir. Okay, because he has given all the details about this NST. And apart from that, if you're looking for some good premium quality content, okay, you should definitely check out on our website operating system course, which is available already free of cost. That is like premium stuff without any payment you are having. Okay, you should definitely check out that, so that you can get the feel of that how does a premium course looks like. Okay, a high quality content looks like. Apart from that, you should definitely connect with us. You can you go to our website. Okay, you should explore that. We have a Telegram group, you can join that, and we have this WhatsApp channel as well. So scanning these, you can definitely reach up to us. Okay, so now I would be leaving. I would say bid bye to you guys, and see you guys in the next session. Right now I would say best of luck for your results. Okay, so see you guys in the next session. So I would be leaving this session now. So yeah, now he would be joining, Tathagat would be joining. Okay, so bye guys, best of luck for the results. Now I would be leaving. I would
Okay, so hello everyone. I'm Tathagata, and I guess some of you already might know me. Sachin sir has already discussed a handful number of questions, very interesting questions that came in the second paper of GATE CS 2024. Okay, so a brief introduction about myself. If you don't know me, I'm Tathagato De. I secured All India rank 21 in GATE Computer Science, and I am in my final year of MTech in Computer Science from IIT Bombay. I'm going to join Coupa Software as a data scientist. I also cleared JEST exam, I cleared BARC interview, and have 1+ years of teaching experience. And today in this session, after Sachin sir, we are going to discuss some more questions on programming and data structure. Very interesting questions. So, without further ado, let's start the question. Remember, guys, these questions are mostly memory based that we receive from our students. So there can be some issues or some changes in the question, but the way we received it, we are trying to deliver the best top-notch solution on that. So this is a question on programming, and the question says there is a script given. So int main, array of double. Okay, it is double. The data type is double, and the array given is 20.0, 25.0, and two pointers are given. Okay, next line says that p equals to a and q equals to p plus 1. Then printf. Printf percent %d. The format specifier is percent %d. You have to carefully look into these. What is the data types and everything. Okay. And the next one says, okay. So this is the question, right? Yeah. This is the question. And as usual, the output is asked here. Okay. What will be the output? So I guess this was a numerical type question, or there was options. There was options. Let me just write out the options. 4, 8, 8, 5, 1, 5, and 1, 8. Okay, so this was one of the easier questions. So if you want to answer it, just let us know what is your answer on this, and I'll solve this right now. Just a second. Yeah. Okay. So let's see. Yeah. So it says the array of double basically. So यहाँ पे array बना लेते हैं first में. So there is an array 20.0, 25.0. I'm sorry, this is not 250. This is 25.0, and it is named as A. So it is a genuine concept in that key. The name of the variable basically returns the address, the location in the memory of the in case of 1D array, the name of the variable returns the location of the first element. In case of 2D array, the name of the variable returns the location of the first 1D array. So here, A basically returns, suppose this is location 1000, this is then location 1000, and suppose 8 bytes of double, so 1008. And pointer P and Q are initialized. So what is that? Basically, P is a double pointer data type. P and Q. They are initialized with garbage values. Then P equals to A. What does A return here? As I said, A will return the location of the first element. So 1000 will return. So P 1000 is stored in P. Then Q equals to P plus 1. What is P plus 1 here? P is 1000. P is 1000. And what is the data type of P? P is pointer to double. So P plus 1 will point to the second location of storing the double values. The second location here, what is uh, yeah. So what is the second location here? 1008. So P is pointing here, Q is pointing here. Now it says percent %d. What is percent %d? This is the format specifier. Percent %d format specifier is for integers, right? It is for integers. Now it says integer Q minus P. Q minus P. What is Q minus P? Q is 1008 minus P, 1000. So will it return 8? Will it? What do you think? No, it will return 1 because Q and P both are data types are pointing to doubles. So there is basically one element in between. This is the concept, this is how pointers work. So it will return 1 because 1008 minus 1000 is the location for just one double element there. Okay. Yeah. So yeah. So this value is 1. Now coming to this value, pointer q minus pointer p. What is pointer q? Pointer q is getting into this location. It will give 25.0. What is pointer p? Getting inside this location. It will give 20.0. What is the result? 5.0. But convert typecast into integer data type. So converting into integer will give 5. So this will print 5. 1 and 5. Is there an option 1 and 5? Yeah. Option C is the right answer. Okay. Moving to the next question. Once again, guys, these are memory based questions. So there can be some changes or some, can be in a different question. So let us know in the live chat, in the comment section, what is the exact question was and how was your paper. Okay. Okay. So let's see this question. This question says there is a graph given. Let's draw the graph. I think I got it right from the student, our beloved students. They have appeared in the GATE exam, and yeah. So this was C, and this is D. F. This is E, and there is a node in between G. This is connected. This is connected. This is connected. 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 This is connected. One, one, two, 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 three, two, three, two, two, one, and this. Okay, so he missed it. I think this is one also, and cost of minimum spanning tree is asked. Cost of minimum spanning tree. Okay. Once again, so this graph is also memory based. There can be changes. This is very highly volatile. So even if the question is like if the values change, the number answer can be changed. But depending on this particular graph, I'm drawing the answer. So how basically should we compute the minimum spanning tree? Using Kruskal algorithm. So when we are doing by hand, Kruskal algorithm is the best way, I feel. And this is in general. So how the Kruskal algorithm basically works, you have to pick the minimum costing edge in the graph that is not forming this cycle with the spanning tree. Okay. So what is the cost edges here? One, 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 one. Let's pick them. So first I'm taking AB. Good. Then I'm taking AF. Is it forming a cycle with AB? No, definitely not. Then I'm taking CD. Then I'm taking ED. They're not forming cycles. Okay. So now we have edges with weight 2. So let's pick them. Suppose I'm taking AG. Is it forming a cycle? No. Then what about BG? Will it form a cycle? Yes. ABG will be a cycle. I can take it. Then what about CG? I can take it for sure. Then DG. Yes, it will form a cycle of CBG. Then EG. Can't take it. CD, EG will be a cycle. And FG also cannot be taken. So uh, is all the nodes properly connected? Is every all the nodes are connected? Yes, all the nodes are absolutely connected, and everything is in place. Okay, so we got one information. No, this was of two. This was two. So this will be two. Still two because we are taking edges of weight two. So this can also be taken. And now this all the nodes are connected. A, B, F, G, E, D, C. All the nodes are connected. So a tree basically is formed, and we do not need to add any more edges into that. So 1 plus 2 plus 2 plus 1 plus 2 plus 1. What is it? 9. So 9 is the answer. 9 is the right answer. Thank you for getting in right time and informing us the right value. So this was another question. Okay, so once again, guys, this is you can check out our webpage, which is mindmatrix.net. We are providing premium courses on GATE CAC and GATE DA. And the best thing about this is if you buy GATE CAC or GATE DA or the combined package, in that you are getting a placement preparation course for free. This is very helpful. I'm from IIT, and our other faculties like Sachin sir was from ISC Bangalore. Anshu sir will be coming up next. He's from IIT Kanpur. We know that placement prep packages, how helpful that is when you get into the top institutes. It is very useful, even if you are trying to get into some companies. That is very useful for your case. We are giving it for free with all of our other courses, and the prices are very reasonable right now. It is discounted price. You can check in that. And also, if you want scholarship, our national scholarship test is coming up. It is on 17th Feb. It is on 17th Feb. You guys can register for it free and appear on our test. The test will be, we are giving up to 100% discount, which is you will be getting all the premium courses, all the top-notch content for free. And also, you can check out our operating system 2025. Anshul sir is teaching this course. You can register for it for free and check out our content quality, our delivery, and the way we teach, the way we deliver our knowledge base and everything. You can register for it, study, and join our family and register for our premium courses. Okay, so let's try one more question. I have one more question. This is on data structure. This question a bit lengthy, so I will request you guys to have some patience. This question is a little lengthy, not that much, but a good question. Actually, a good question. Okay, so it says that there is stacks. There are two stacks, S1 and S2. Yeah. So S1 capacity of S1 is 4, of S2 is 2. Okay. Now S1 has some elements. S1 has some elements, which is 100, 200, 300, and 400. And S2 is completely empty. Okay. Now you are allowed to do three kinds of operations. Operation one, operation one. These are operations. Okay. These are operations. Operation one. Operation one is pop from S1 and push to S2. Operation 2 is pop from S2 and push to S1. And operation 3 is pop top of stack of S1 and give as output. This is output. Okay. Then, then the question says, okay, the question says there are four options, say 200, 300, uh, just a second, 200, 300, 400, 100, 100, 200, sorry, yeah, 200, 400, 300, 400, 200, 100, 300, and last is 300, 200, 400, and 100. Okay. Okay. So, are there any questions on the previous, any doubts or anything on the previous questions? I don't think any doubts are there. Yeah. Okay, so let's move ahead with this question. Okay, this is a very interesting question and will not take that much of a long time. I hope you understood the question. The question says there are two stacks, S1 and S2. S1 has capacity of 4, S2 has capacity of 2. Okay, and S1 has these elements 100, 200, 300, 400. S2 is empty, and we are allowed three kinds of operation. Pop from S1, push to S2. So popping the top of stack from S1 and pushing that exact element into S2, then popping the top of stack from S2, pushing that into S1, and then popping the top of stack from S1 and out give that as output. Then out of these four, which are can be generated as output using these operations? Okay, which of these can be generated as output? Okay, let's just try out. So S1 here, okay, 100, 200, 300, and 400. I will just show you the operations one by one to recreate the situation. Okay, so we are so let's try out the first option. Pop this one Pop this one. Good. Then 200. So operation 3. We are popping that and showing as output. Then here is 300. So all of the nothing is there basically out of these three. Okay. Then we are popping this and presenting it here. Then pop that and present as output. Okay. So this is also done. These two are empty now. And then we want 400. Okay. So pop that and present, push it here. This is S2 is empty. Then pop this into output, pop this into output. Done. So this can be generated. Moving to the next one. Moving to the next one. Okay. 100, 200, 300, 400. Let's just give you some visual representation of how that can work. So we want 100, right? So remove all these three and we are popping that into S2. So first 400, then 300, then 200. Now see, um, yeah, so 100 and 200 is good. But if like we can pop 100 from here, then push 200 here, get out 200 here. Then if we push 300 here. Okay, so was this, just let me check it again. Let me check it again. Yeah. Okay. So this is like, let's see, 100, 200, 300, and 400. So 100 was here, and I did a mistake here, actually. I think let's, yeah, 300, 400. So 400 will be here first, then 300, popping 300, pushing it into here, popping 200, pushing it into here. Now 100 is there. 100 is output. 100 is output. Okay. 100 is output. Then this stack is totally empty right now. This stack is totally empty right now. Then pop 200. 200 is here. Pop 200 from here. 200 is presented as output. 200 is presented as output. 200 is gone from here. Now 300. 300 comes here. 300 comes here. Now 400. 400 also comes here. 400 also comes here. Now 400 is output. Then 300 is output. So we can generate this one also. Okay. We can generate this one also. Moving to the next one. Moving to the next one. So 100, 200, 300, and 400. Okay. So we want first 400. Okay. Very well. Then we want 200. So pop this and present here. Push it here. 200 is output. Then we want 100. 100 is given. Then pop 300 and write it here. Then 300 is also generated as output. Okay. So this one is also correct. Okay. So getting into the last one, last option. Will it be correct? What do you think? Let's see. All right. So again, write 100, 200, 300, 400. So first we want 300. So pop 400, push it here, pop 300 into output. Then we want 200. Pop 200 into output. Then we want 400. Pop from 400 from here, push it here. Then 400 goes into output. Then 100 is there, 100 is also. So all the options are correct. And you saw exactly, so solving this question is basically how the compiler works. You have to think like that to get into the right notches, how what output can be generated. Okay. So these are the questions and that we received right now from our students. And yeah, so Anshul sir will be joining next. And guys, just to remind you that our national scholarship test is coming up. That is on 17th February. We are giving up to 100% discount on that, up to 100% discount. So 100% discount on our GATE CAC, GATE DA, and also combined package. In that, another big surprise, you are receiving complete placement preparation course in along with these two. Okay, and also you can register for operating system course for free. You can try out our top-notch content that we are delivering. Our faculty. I'm from IIT Bombay. Sachin sir was there. He's from IISc Bangalore, and Anshul sir is joining right now with a lot of more questions. He's from IIT Kanpur. We are from top institutes, and we are delivering the best content. We know that. you will require to get a 2 digit and top rank for in GATE exam and get into top institutes. So we'll be working together in solving that. Join our courses, our premium courses right away. You can also avail scholarships, appear on the test on 17th February and also register for this course. Also, you guys can join with us in our Telegram channel, our WhatsApp, and our website. So we are responding to each and every student very closely, individually. We'll be helping you, working together, solving your doubts and other questions. Okay. So I will now bid goodbye, and Anshul sir will be joining. I will just inform him. I think he's joining. Okay, some more questions on OSBBMS networks is there that we received from our students. Okay, so hi.
Okay, hello everyone. Welcome to MindMatrix. So here we are with a lot of questions now we are going to solve, and already Sachin sir has solved few questions. Tathagat sir has solved few questions. Now I will be solving 14 to 15 questions at least in this, and so stay tuned and also like this session, share with your friends and subscribe. So this is all my credentials. You can read it out. You can pause this. You can read it out. So without wasting time, let's start the questions. And before that, just important information I want to share that we are having this national scholarship test for all those students, those who want to enroll in our course, those who are interested and they want some scholarship, they want some discounts. So definitely you can enroll for this. Link is given in the description and also pinned up in the comment section. You can just click on it and you can register for this national scholarship test. And all India rank 1 will be getting 100% discount, and there are discounts for all the ranks. So you can just visit it and you can register for it. Operating system course I'm providing for free, and that is the top notch quality content you can get you are not going to get anywhere else, I can assure you that. So you can also enroll for it for free. Fine. So let's solve the question first. So that is first question we are going to solve here now from computer networks. So it is given that question was which one of the following CIDR prefix exactly represent the range of IP addresses 10.12.2.0 to 10.12.3.255. Options are given to us, that is 10.12.2.0/24. Option B is given 10.12.2.0/22, 10.12.0.0/22. Option D is 10.12.2.0/23. So this is given to us and this is MCQ question. This is MCQ question. Only one answer is correct. So let's quickly solve this question. So we know in case of CIDR, let's first consider this. So if we talk about all these options, let me just directly jump to the solution. So basically, if I consider option D here, I'm going to explain how we are getting option D. So here 23 represents the NID bits. So NID is 23 bits. HID, host ID bits is 9, because out of total we have 32. So out of that 9 bits are for host ID. So if I talk about this option D, so here we have 10.12.8 times 4 times 0, 0, 0, 1, 0, because we have 2 here. So 23 bits for NID, so 8 bits, 8 bits, 16 bits, and here just except 1 bit, all bits are belonging to the NID bits. So here we can say 8, 8, 16, and here 8 bits. I mean 7 bits, that is 23 bits for NID, and then we have 8 bits here. So total 9 bits belong to the NID. 9 bits belong to the NID. So I hope it is clear. Now we need to find out the exact CID prefix which is representing these range of IP addresses. So it is very simple question. What we have to do here is just in the NID, what you can do is from 0 0 till all ones we can make all the HID bits. This is HID bits, this is NID bits. So you can make all the HID host ID bits as one, because it is going to range. These NID bits is going to remain same, right? But these are going to change. So if you make all ones here, this is what you are going to get. This represents 10.12 point. This is going to be 2.02. This range represents 10.12 point. This one here, this one is there, so it is going to be 3 here, so 3 point, and these are all ones, so it is going to be 255. So as we can see, this is what we want. So only option D is the correct answer, which is representing exactly these range of IP addresses. I hope it is clear and you have answered that question correctly. Now let's proceed to the next question that we have from COA, Computer Organization and Architecture. So 4 instructions are given to us. I1 instruction formats are given to us: I1, I2, I3 and I4. And I1 is a division operation. We have R3, R1, R2, which represents R3. We are storing the result of division of R1 and R2. Here we have subtraction operation, R5, R3, R4, and we are storing the result into R5, that it means R3 minus R4. Third instruction is addition instruction. We have that is R3, R5, R6, and we are storing the result into R3. So here we have R5 and R6. I4 is a multiplication instruction. We have R7, R3, R8, and we are storing the result into R7, multiplication of R3 and R8. So what do we need to find here? We just need to check the dependency. We need to check the dependency. Option A says war dependency, that means right after right dependency on R3 between I3 and I4. So between this instruction we need to find out. Okay, and then second one is your war, that means right after read. So dependency on R3. So basically in the question they are just asking about R3, okay, not any other register, just on the R3 we need to find out what kind of dependency is there between I1 and I3. Option C says raw dependency on R3, that means read after write between I1 and I2. Option D says raw dependency on R3 between I2 and I3. So that we need to find out. So again here this is also MCQ question. This is also MCQ question. Now carefully see this. Let's talk about option A first. Right after write I3 and I4. So we have I3 and I4 here. Do we have right after write? Here it is, we are writing into R3. Here we are writing into R7. So definitely this is incorrect. We are not having right after write dependency on R3 here. What about second option? Right after read between I1 and I3. So I1 and I3. Right after read. So we have to check for R3. So here we are not having right after read. Again this is, we are storing into, we are writing into R3. Here also we are writing into R3, so it cannot be right after read. So this is also incorrect. What about option C? Read after write between I1 and I2. So it is talking about these two instructions. Read after write. Is it correct? We are reading the value of R3 and here we are writing. So we are reading after writing it. So yes, there is a dependency on R3 between I1 and I2 instructions. So option C is definitely correct. What about option D here? Read after write on R3 between I2 and I3. So it is talking about these two instructions now. Read after write. Here we have right after read, because after reading the value then we are writing it. So that's why this is also incorrect. Option C is the correct answer for this question. So I hope you have answered it correctly. Now now let's solve another question based on compiler design. So the question says, question is from compiler design and it is a numerical answer type question. A grammar is given to us like this: S derives SS or AA or BAC or BC or BBA. A derives D hash, B derives @ Clear? This is what given to us. We need to find the closure 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 on I naught when we give S, when we see S is the input. So closure of I naught we need to find out. It is very simple, and we need to find the number of items go to I naught comma S. It is a very simple question. Let's see how to solve it. So we have this, right? So consider this when we have a dot on S. So basically whatever is derived by S, we are going to get it. We are going to write here. So carefully see here. We have this dot S. We need to find the closure of S first. So we are going to have dot SS, and we are also going to have dot AA, dot BAC, dot BC, dot BBA. Similarly, we have the closure of A also, because we have a dot in front of A and in front of B. So we need to write dot D hash here, and B derives dot at the rate. Clear? So this is what we are going to get. This is what we are going to get. Now this is I0 state. Now we need to find the closure on S. Now we need to find the go-to on S basically. So go-to on S, that is also very simple. So after go-to on S, what you are going to get? S dash, you are going to get S dot, and this dot will also shift. So you are going to get here S dot S, right? This is what we are going to get. And finally, we are again going to find the closure of S. So you are going to get all these again. You are going to get all these again. So we can just write dot SS, dot AA, dot BAC, dot BC, dot BBA. And similarly, we need to write the closure of A also. This is finally what we are going to get here. So how many number of items we have here is, the number of items we have here is it is very simple, right? How many items are here? Yes, am I audible to you, everyone? I hope am I audible? Okay, fine. Yes, now I'm audible, right? Okay, so number of items here is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So total 9 items are there. 9 is the correct answer for this question. So I hope you have answered this question correctly. Let's solve another question on computer networks. Let's solve question on computer networks. So it is based on Ethernet. It is based on Ethernet. What we have in the question is bandwidth is given 10 to the power bits per second. Distance is given to us 500 meter. Speed is given to us, that is 2 into 10 raised to the power 8 meter per second. What else we have? Now we need to find the frame size. So minimum frame size we need to find out. Minimum frame size we need to calculate in bits. That is very simple. Ethernet uses CSMA-CD. So for that, the transmission delay is always greater than twice of propagation delay. Yes or no? So we can also say transmission delay is nothing but L by B. L is the frame size, B is the bandwidth. So here 2 into propagation delay is nothing but D by V. That is the distance between the source and destination. And here it is the speed. So we can also rearrange this. We can write L is greater than equal to twice into D by V into bandwidth. And we can substitute the value. So distance is 500 meter, speed is 2 into 10 raised to the power 8 meter per second, and bandwidth is 10 raised to the power 8 bits per second. So everything will cancel out, and finally you are going to get the minimum frame size as 500 bits. 500 bits is the correct answer for this question. That was from computer network. Now let's solve a question from digital logic. See, we are going to solve the questions from all the subjects, whatever questions we have received so far. So this is a very simple question from digital logic. So this is given to us 2 to 4 in base 5, and options are given to us. We have to find the equivalent in different bases. We need to find the equivalent numbers in different bases. 50 base 16. Here we have 100 base 8. Here we have 64 base 10. So we can convert this into decimal. So we know how to do it. 2 into 5. So we can directly apply the shortcut. Basically 2 into 5, that is 10 plus 2, 12. 12 into 5, that is 60. 60 plus 4, it is going to be 64 in base 10. That means option D is definitely correct. What about other options? So if you check here, convert all these options. You don't have to convert base 5 into base 7 or base 16 or base 8. No, just convert everything into base 10 and then compare which one is equivalent. Okay, so if you do this, 1 into 7, that is 7. Plus 2, that is 9. 9 into 7, 63 plus 1, that is going to be 64 again. So this is also equivalent. What about this one? 5 into 16, that is 80 plus 0, 80 only. This is not equivalent. Option C, it is going to be 1 into 8 plus 0, that is 8. 8 into 8, 64 plus 0, that is 64 only. So option C is also correct. A, C, D is the correct answer for this question. A, C, D is the correct answer for this question. Let's solve another question. That was again a really simple question from digital logic we have, right? And we have to find which one is false here. So option A is x dot 1, basically AND operator is equal to x. B says x or x complement is equal to 1. 1 or x is equal to x. D, x and x is equal to 0. We need to find which one is false here. We need to find which one is false here. If you are performing AND operator here, definitely it is true, right? So basically the answer depends on the value of x. If you're taking x is equal to 0, answer will be 0. If you're taking x is equal to 1, answer will be 1. So definitely it is true. We need to find which one is false. X or x complement, 1 or 0. If you're performing OR operation between 1 or 0, you will be getting 1. This is a very simple question. This is true. 1 or x. 1 or x, 1 or anything is 1 only. So this is false here. This is false here. And this one, x and x. Let's say x value is 1. 1 and 1 will give you 1, not 0. So this is also false. Option D is also correct. This was MSQ question from digital logic. Very simple question. C and D is the correct answer for this question. Let's proceed to the next question now. So we have another question from computer networks. Which of the following field of IP header is or are always modified by any router before it forwards the packet? So option A says source IP. Option B is header checksum. Option C says TTL, that is time to live. And D says protocol. So which one we are always going to change? Header checksum, yes, it is going to change. Time to live also changes whenever we forward the packet on any router. So B and C both are correct for this one. MSQ question. It was MSQ question. Now let's solve the next question now, and that is so that is from digital logic again, from number system. So we need to find the largest among all. And it is based on single precision. So option A, so we have sign bits here, we have exponent bit here, we have mantissa, right? Option A, B, C and D. So option A, that is 0. Here it is given 0, 1, 1, 1, 1, 1, 1, 1. Right, and here it is 23 zeros are there. So I hope you know that in case of single precision, we have 1 bit for sign, we have 8 bits for exponent, and we have 23 bits for mantissa. Total 32 bit of register is there for single precision. What in option B, it is given all bits are sign bits are 0 in every option. Here we have 0, 111, 1111. Here we have 23 ones. Okay, in option C we have 4 times 1, 1110. Here we have 23 ones. In option D we have 8 times 1, 23 ones. Clear? Okay, so now we need to find which one is largest. Here? It is a very simple question. Like my past students can tell you, like when I covered digital logic. So it is a very simple question. See, option D you can directly eliminate. Why? Because we know this, that if exponent is 0, there are 2 cases. If exponent is 1, there are, when I say 1, that means 255. not 1, 255. That means all ones. So in that case, if m is equal to 0, mantis is equal to 0, it is going to be infinite. If mantis is not equal to 0, that means it is anything, it is going to be not a number. So here you have exponent as all ones, you have exponent as all ones, so that is why. And mantis is not equal to 0, so that is it is not a number, so you can directly eliminate option D. Option D is not the answer. Now we need to check A, B and C. A, B and C. Here if you see, we have 23 zeros. We need the largest number, right? So if we need the largest number, definitely we should have all ones. So here 23 zeros are there, so definitely option A is also not correct. Now we have to choose between B and C. So this is based on option elimination simply. You don't have to calculate the values of every option. I hope you are getting it. So if you see the option B here, here also we have 23 ones, here also we have 23 ones. Now it all depends on the exponent value. The number which is going to have the higher exponent value, that is going to be the largest. So here if you compare these two, definitely this is going to have the highest value. So option C is the largest number here. I hope it is clear to all of you. Guys, do like the session, share with your friends and subscribe to MindMatrix. We are giving every effort to give you the best content in our paid classes, also on our YouTube channel. You can also connect with us. I'm going to solve more questions now. You can also join Telegram group, doubt discussion group. More than 1400 students have joined already, and this is our WhatsApp channel. You can also visit our website for the premium courses. Now without wasting any time, let's solve some more questions now. Okay, so here we have another question from COA now. So frequency is given to us, that is 4 megahertz. So it is based on DMA. It is based on DMA. Okay, let's solve this question now. So here we have, okay, fine. Just a minute. Yes, where it is. Yeah, so it is based on DMA using cycle stealing mode. So I hope you know that in DMA we have two modes, burst mode and cycle stealing mode. So it is talking about DMA transfer 8 bytes in. It is given in the question that 8 bytes can be transferred in one cycle. We need to find the DMA transfer rate. So it is also not a difficult question. If you know the concept, you can easily solve this type of question. So let's do it. So we know that it is given that 1% of processor, 1% of processor cycle used by DMA is equal to what? Is equal to what? Preparation time. That means the data preparation time, and in the numerator you will be getting the transfer time. You will be getting the transfer time into 100%. So percent will cancel out. What you are going to get? 1 here and here. What is the transfer time? Frequency is given to you. So you can find out the transfer time. So it is going to be 1 by 4, right? Megahertz, it's 10 raised to power 6. So it is going to be 10 raised to power minus 6. So finally you are going to get 1 by 4 microseconds. 1 by 4 microseconds divided by the preparation time. I hope you are getting it. So preparation time is equal to what? So here we have 100 also, multiply by 100 also. So 100 divided by 4 microseconds is your preparation time, or you can say 25 microseconds is your preparation time. Clear? Now we need to find the data transfer rate. Let me just erase this. So data transfer rate. So in 1 second, how much data we can transfer, how fast we can transfer in 1 second. So it is going to be nothing but, so here we can easily find that it is going to be 8. We know that in the question it is given 8 bytes in one cycle. 8 bytes in one cycle. So we say 8 into 4 into 10 raised to power 6 divided by 100 is going to give me the data transfer rate. Why? Because in 25 preparation time is 25 microseconds. So in 1 microsecond, in 1 second basically, how much it is going to be? 25 into 10 raised to power 6 is going to be, in that on the other side, and here we are going to get 8 bytes. So 8 bytes into 4 into, basically it is 25 only. So we can write 8 into 10 raised to power 6 divided by 25 only. Clear? This is what we are going to get. So here I have just directly written that 100 by 4 is 25. You can also write like this. So this is what you are going to get, and finally if you solve this, you will be getting 32 4 times 0 as the data transfer rate. Clear? Clear? So that was not a difficult question. Now we are going to solve one more question from COA. So let's solve it. And this is a numerical answer type question. We have a non-pipeline processor. Of 2 gigahertz, right? And average cycle is given, that is 6 here. Average cycle per instruction is given, that is 6. Pipeline processor is also of 2 gigahertz. Then it is given in the program, a program is taking 20% of the program, it is taking 2 stall cycles. So I'm not going to write entire question, I'm just writing whatever the important information that is there in the question. So a program for 20% of instruction it is taking 2 stall cycles, for 20% of instruction it is taking 3 stall cycles, right? And we need to find the speed up. Factor. Again, not a difficult question if you know the concept of pipelining. That is a very simple question. So let me tell you the effective time for non-pipeline you can find, that is going to be what? The CPI that you have 6 into, if you find out the time of this is frequency is given, so it is going to be 0.5 giga is 10 to the power 9, so it is going to be a nanosecond. So 0.5 nanoseconds, so that will give you 3 nanoseconds. This is the effective time of non-pipeline processor. Now let's talk about pipeline processor. So here for 20% of instructions it is taking 2 stall cycles, for 20% of instructions taking 3 stall cycles. So if you have 100, for 20% it is taking 2 stall cycles, for 20% it is taking 3 stall cycles, rest for 60% it is taking 0 stall cycles. Fine. So we can find, let me do it here now. So we can find the number of stalls per instruction. We can find number of stalls per instruction. That is going to be very simple. 20% into 2 plus 20% into 3 stall cycles. Rest for 60% it is 0 stall cycles. So that is going to give you 0.4 plus 0.6, that is nothing but 1 only. Now we need to find the average instruction time. Average instruction time for this pipeline would be what? Ideal CPI, that is 1, plus the number of stalls per instruction, that is 1, multiply by the cycle time. Cycle time is, again, for pipeline processor also we have 2 gigahertz, that means 0.5 nanoseconds. So 0.5 nanoseconds. What do you get? 2 into 0.5, that is going to be 1 nanosecond only. Now we have the effective or average instruction time for both non-pipeline and pipeline. So speed up is going to be what? Speed up is what? Speed up is a performance of a pipeline processor divided by performance of non-pipeline processor. What is performance? Performance is inversely proportional to the effective time. So can we say it is going to be inverse? So effective time for non-pipeline, effective or average instruction time for pipeline. For this it was 3 that we calculated. For pipeline it is 1. So finally the speed up you are going to get is going to be 3. Is it clear to all of you? If you have any doubts so far, please ask. So this type of questions can be solved if you know the concept quite well. Fine. So now what we are going to do is we are going to solve another set of questions. Before that, just let me tell you one thing. Those who are new to our channel, we are going to conduct National Scholarship Test on 17th of Feb, 6 p.m. So you can register it for free. The link is given in the description, also pinned up. We have pinned up that comment. You can see and you can register for it. You will be getting huge discounts on our all premium courses. Right. Now let's see another question from computer networks. So which of the following statement about IPv4 fragmentation is or are true? Basically, we need to find the true statements based on IPv4 fragmentations. So option A is saying fragmentation. Option A is saying fragmentation of IP datagram. Fragmentation of IP datagram is performed only at source of the datagram. Is it true or false? So can we perform the fragmentation only at the source? No, that is incorrect. That is incorrect. Why? Because the fragmentation can be performed at the source and it can be performed at the router also. So that is why this statement is false here. What about option B? Fragmentation of IP datagram is performed only at, or the option says at any router which finds the size of datagram greater than MTU. Is it true or false? Yes, at any router where the maximum transmittable unit size is less than the size of the datagram, definitely we are going to perform fragmentation. So this is true. This is true. Option C is it is talking about the reassembly. It is talking about the reassembly. So reassembly of fragments is performed at all immediate router from source to destination. Is it true or false? Where we perform reassembly of the fragments? We perform reassembly of the fragments only at the source, not at any immediate router. That's why this is false. This is also false here, right? So we have to find true. So as of now, B is only true. What about option D? Option D says reassembly of fragments is performed only at destination. So as I told you, reassembly of fragments can be performed only at the destination, not at any intermediate router. Any intermediate router. Only at the destination we can perform the reassembly. So this is true. This is true. So option B and D is true for this question. Now let's solve one question from DBMS. So we are going to solve now one question from DBMS. And here we have this ER diagram given to us. One entity is given, one identifying relationship is given. We have one entity E2, which is a weak entity, and here we have the total participation. So option, we have to find the correct one. So option A says neither weak entity set nor strong entity set must have total participation. Very simple question, very basic question, I would say, right? So option A says neither weak entity nor strong entity must have total participation. This is false. This is false. Why? Because भाई total participation weak entity का तो होगा ही होगा definitely. Weak entity set is going to have, must have total participation, right? So that's why option A is incorrect. Option B says both entity set must have total participation. No, it is not mandatory. Yes, weak entity set must have total participation, but it is not mandatory for strong entity. It may or may not have. That's why this is also false. That's why this is also false. Both set must have total participation. No, that is not mandatory. The owner entity must have total participation. No, that is again false here. That is again false here. Option D says simply the weak entity must have total participation. Yes, this one is true. It is mandatory for only for the weak entity to have total participation, not for any other entity. So that's it from this DBMS. Now we are going to solve. Now we are going to see one question from compiler design. So there, that was match the following. We had two sets, set X, set Y. The first one is lexical analysis. Then we have a syntax analysis. Then we have intermediate code generation. Then we have code optimization. We need to match. We need to match this. Okay. Here we have abstract syntax tree. Here we have a token. Here we have parse tree. And here we have constant folding. That is one of the technique of optimization. That is one of the technique of optimization. We need to just match, and on the basis of that you have to answer the, in the options. Lexical analysis, definitely it is related to token. Syntax analysis, it is related to parse tree. Intermediate code generation is related to the abstract syntax tree, and code optimization is related to the constant folding. That is one of the technique of code optimization. I hope it is clear to all of you guys. Do like the session, share with your friends, and subscribe to MindMatrix YouTube channel for the best quality content for both GATE CS and GATE DA. Right, so let's see now the next question that we have again from compiler design. The grammar given to us is like this: A, B, 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 A, C, S, epsilon, epsilon, and here we have a ds and epsilon. Clear? This grammar is given to us. Apart from that, a table is also given to us. So here we have A, B, C, D, and dollar. Fine. Now we need to find what we are going to fill at these numbers. So basically options were given and we need to find what we can fill at these numbers. So it is very simple. You had the options, but I'm directly going to solve this question for you. Now carefully say this. If I talk about this C, so do we have epsilon production here? Do we have epsilon production in case of S? No, we don't have epsilon production. So we just need to find the first of S. If I find the first of S, what is first of S? That is first of A. What is first of A? That is small c. What else? If I substitute small c here, that is going to be first of S. If I substitute epsilon here, then first of S will become A. So A is also first of S. Here also first of S is first of B. First of B is D here. And if I substitute epsilon, then first of S will become B also. So C, A, D, B is first of S. So now here in the column C, what I need to fill at the first? So how we are getting C? Due to which production I'm getting C? Can I say due to this production A, B, I'm getting C? So can I say the first one is nothing but S derives A, B. Due to this production, I'm getting a C here, right? So first one represents this production. What about D? I'm getting D due to this production, right? When I find out the first of B, that was D. So that is the reason why I'm getting B here. So in the column D, I'm going to substitute B, 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 A. Is it clear? What about third and fourth? What should be third and fourth? So we are getting A and B, but due to which production? So here if you see A, we have, if I calculate first of A in the row A, if I need to calculate the first of A, that is C, and first of A, this epsilon also, right? So in that case, when I'm calculating first of C, in that case we need to find out the follow of A, follow of S. So in that case, due to this production, A derives epsilon, I'm getting this, and B derives epsilon, I'm getting this. I hope it is clear to all of you. I hope it is clear to all of you. So when we don't have epsilon productions, we just need to find the first of S, first of left side, and when we have the epsilon productions, in that case, like here if you see, let me explain you it more clearly if you are having any doubt. Here if you see, carefully see, here first of A is having epsilon. So in that case, we need to find the follow of A. Follow of A. What is follow of A? That is small a. Anything else? No. So that is why due to this production, we are having this fourth one and third one. Similarly, you need to find the follow of B also. You need to find the follow of B also. Follow of A is A, follow of A is B also. So A comma B. Similarly, follow of B is B and follow of B is A also. So in both A, B, but we need to find the third one in row A for column B. The third one is going to be what? Third one is going to be A derives epsilon, because due to this production we are finding the follow of A, which is B. And here in the fourth one, we are finding the follow of B due to this B derives epsilon production. So that's why 4 is this one. I hope it is clear. I hope it is clear. So I'm solving these questions very quickly for you so that I can answer all the questions. So that's it. We have answered most of the questions. So that's it from my side, and you can enroll in our premium courses. So we are 3 faculties who are teaching at MindMatrix. Myself, Anshul, you know my credentials already. right? We have Sachin sir, who has secured all India rank 70, and he is pursuing his MTech in AI from ISC Bangalore, right? And he is expert in data science and AI. And we have Tathagat sir, who is from IIT Bombay. He has secured all India rank 21 in GATE, and we all are placed in big companies like Juniper, Louis India, and Coupa Software. But we have started this because we know that we can deliver the best content possible for to all of you. And you can register for this national scholarship test. You can enroll it, register it, and you will be getting heavy discounts, huge discounts on all our premium courses if you score well in this national scholarship test. If you really want to check the content quality now, you can just enroll for this operating system 2025. That is for free. That is for free. Just enroll for it. All the links are given in the description. Enroll for it and check the quality yourself. Okay, then only decide whether you want to enroll in our courses or not. That's it. That's all up to you. Also, I'm telling you that we are providing placement preparation entire course already included in this GATE CSE, GATE DA, and GATE CS and GATE DA combo. Apart from that, we are providing the practice question, tests, video lectures, class notes, one-to-one mentorship, doubt discussion group, everything. This is a complete package. Apart from that, we are also providing the projects for AI and data science. If you are preparing for GATE DA, so we will be providing the projects, and we will be explaining you the project step by step, everything. In placement preparation course, we are going to solve live 200 DSA questions, live 200 DSA questions. So this is what we are giving you as the extra already in these premium courses in GATE CS and GATE DA, right? Our GATE CS, GATE DA content, we know that is the best, we know it. Apart from that, just as a as a compliment, we are giving you complimentary, we are giving you the placement preparation course, the entire placement preparation course, which is having the OOPS, system design, 200 live DSA questions, interview questions, projects, everything in these premium courses already included. So, and live classes have already started. I'm teaching operating systems. Sachin sir is taking probability and stats in GATE DA. So why wait? Enroll for it. You can visit our website if you want. If you're waiting for some discount, so you can go for this national scholarship test. We are going to conduct it for on 17th of February 6 p.m. So you can register for it and you can enroll for it. Clear? So that's it from our side. We have solved a lot of questions from both shift 1, shift 2 for GATE CS 2024. So that's it. I will see you in the next session, upcoming session on YouTube, and also in the paid courses. Till then, take care, good night, and all the best.